Hello chemistry students, Dr. Tullis here. In this section you will be able to identify functional groups from organic formulas, name and draw structures of alcohols and amines, and describe chemical properties of alcohols. Organic compounds often contain other elements in addition to carbon and hydrogen. Two elements in particular, oxygen and nitrogen, add a rich dimension to carbon chemistry. Here are just some of the functional groups we'll look at. An amide group, a nitro group. There's another amide, a ketone group, an ether group, and there's lots more. You should have a plethora of cheat sheets of organic chemistry functional groups. There's carboxylic acids to esters to amides to nitriles to aldehydes, ketones, alcohols, amines. You'll even see alkenes, alkynes, alkanes, the nitro groups that we talked about in the last section, and lots more. On this page, this is from your book, here's a bunch of common functional groups and derivatives of alkanes. A functional group is a reactive portion of a molecule that undergoes predictable reaction. When you're looking at this and you see an R group, that's just a carbon branch that's off of there. It could be a methane, an ethane, a propane, or an ethene, a propene. You get the idea. It's some sort of a carbon branch that's coming off of there. Obviously, we know that the carbon double bonded to a carbon is an alkene. A carbon triple bonded to a carbon is an alkyne. A carbon group with an OH ending is an alcohol. Here's an example. Here's a carbon attached to a carbon, and we have an OH ending. That's an alcohol. In ether, the functional group has a carbon attached to an oxygen attached to a carbon, or a carbon group attached to an oxygen attached to another carbon group. And amine is when I have a carbon group attached to an NH2. So that R is a carbon group. It could be a 1 carbon, a 2 carbon, a 3 carbon, however many you have a carbon group, that's what that R stands for. An aldehyde is when I have a carbon group, and then off of 1 carbon is double bonded to an O, and then the 4th bond off of that carbon is an H. Here is a bunch more. You can look at what the structure of a ketone looks like, the carboxylic acid, and so on. The first one we'll look at is an alcohol. If one of the hydrogen atoms in an alkane is replaced by a hydroxyl or an OH group, the result is an alcohol. So let's say that I have methanol. Methanol came from methane, where I had 1 carbon and 4 H's. And it said if I replaced a hydrogen with an OH, I now have methanol. Ethanol would be if I had ethane, so 2 carbons, and I took off that H and I replaced it with an OH. So instead of ethane, it becomes ethanol. Let's look at the structural isomers of propanol. So there's 3 carbons. Now this says 7 H's. I'm just going to start surrounding my carbons with hydrogen. So that would be 1 hydrogen, 2, 3, 4, 5, 6, 7. So there's 7 H's, and then an OH. So one of my options here with C3H7, which is 1, 2, 3, 4, 5, 6, 7, and then OH, we would call that 1 propanol, because off of carbon number 1 is the alcohol, the OH group. We could also put that OH, though, if it's not off of carbon number 1, we could put it off of carbon number 2, and we could put it there, or we could put it down here. It wouldn't matter. Could we have 3 propanol? Well, in your head, you might have said if this was 1 propanol on the right, and 2 propanol would be here off of carbon 2, then 3 propanol could be off of carbon 3. Except if I drew it like that, now all of a sudden, I would have to renumber my carbons, because I would name this carbon number 1, and that's 2, and that's 3, and now we're back at 1 propanol. So no, 3 propanol is not an option. So now we've looked at the structure of methanol, ethanol, 1 propanol, 2 propanol. And while they are very similar, they are different. We have CH3OH. We then have 2 carbons in an OH, so that's the difference between methanol and ethanol. The methanol, it's used for fuel, gasoline, making formaldehyde. Ethanol is used in beverages, gasoline again, an additive solvents. The 1-propanol is used as an industrial solvent. 2-propanol is used for rubbing alcohol. We then can have a compound where I had 2 carbons single bonded, so we can see where there's an ethane, and then I have 2 alcohols coming off of carbon 1 and carbon 2, so 1, 2, di, and then the alcohol, and that's used in antifreeze. We then can even have a larger structure where it's used in moisturizers. So the uses are vastly different depending on how big those alcohols are and where the OH groups are found. This shows us the compounds a little bit better than just those straight chains. Here's an alcohol group coming off of a single carbon, so it's methanol, and you can see that it's used in heat. Here's ethylene glycol. We can see there's an alcohol group on one end, another alcohol group on the other, so we have 2 polar parts of that compound, and that is a major component in antifreeze. Alcohols are a derivative of water. If you think about it, alcohols just have that OH ending, but water is HOH or H2O. So an alcohol is just 1 H shy of water. Many alcohols dissolve in water because alcohol, OH, is polar and water is polar. And we know that likes dissolve likes. Now, it does vary how soluble they are. For example, methanol dissolves in water, but butanol is less soluble in water. Ethers have a general formula of ROR. The best known ether is diethyl ether. And if we look at this, notice my O in the center here, and then I have an R group or a hydrocarbon group. And then on the other side I have an R group or another hydrocarbon group. And this name, let's see where they got it. Notice I have a meth-eth. So I have an eth, and then an oxy, and then another eth, and they're single bonds, ane. So see where that name came from, ethoxyethane. Or we can say di, because there's 2, this would be 1, 2, ethyl. We know if a methyl group is a single carbon branch, so an ethyl group is a double carbon branch, so there's 2 of them, so diethyl, and it is an ether because it has the format of a carbon group and then an O and then a carbon group. It does not have a carbon group with an OH on it. So the properties of ethers are very different than those of alcohols. Ethers tend to have lower boiling points than alcohols, and it's only slightly soluble in water. Let's look at an amine group. Alcohols, like we said, were derivatives of water. So we have a hydrocarbon group and then an OH on the end. Amines are derivatives of NH3 or ammonia. So here is methylamine. We have a carbon with 3 H's. So instead of a carbon with 4 H's, this would be methane. To make it an amine, we take off a hydrogen and we add an N and 2 H's, giving me that CH3. So here's my CH3. And then an NH2, which would look something like this. This being my sloppy straight structure, and this being more 3-dimensional looking. We can also have a dimethylamine. So I have a methyl and a methyl, so dimethyl with an amine group coming off of that. We can also have a trimethylamine. Notice off of my nitrogen, I can have a first, a second, a third methyl, so trimethylamine. It's called a primary amine if off of my nitrogen group there is 1 carbon coming off of it. If there is 2 carbons, so here's my nitrogen, there's 1 carbon group, there's a second, then it's a secondary amine. And off of my nitrogen, if there's 1 carbon, a second carbon, a third carbon, then it's a tertiary amine. Notice that I do lose some hydrogens that are coming off of it. Here I have NH2, there's 1, 2 hydrogens coming off of it. But if I add another carbon, that's 1 less hydrogen. Notice it's just NH. And if I have a third methyl coming off of it, then there's no hydrogens coming off of that amine group.